This figure from your textbook summarizes a lot of information about phases of the moon. In this first part of our two-part video on moon phases, we'll discuss why we see the different phases. This student is conducting a simple demonstration that explains moon phases, one you can easily do for yourself on a sunny day. As she is doing, hold a white ball at arm's length with the sun shining directly toward you. Then think about what you'll see as you rotate and look at the ball in the different positions shown. In all positions, half the ball faces the sun and is bright, while the other half faces away from the sun and is dark. But what you or our student sees will change as you rotate. As the red arrows indicate, you should rotate toward your left or counterclockwise to match the direction that the moon orbits around Earth as viewed from above the North Pole. Recall that the moon completes each orbit in about a month, so each quarter turn in this demonstration represents about 1 week. Let's start with the ball, or moon, in this position. Only the darkened or night side faces us, and we are also looking in the general direction of the sun in the sky. We therefore cannot see the moon at this time, so we show only blue sky. We call this a new moon, a name that comes from ancient beliefs that the moon was being remade at this time. Next, imagine that you have turned around and are facing the moon in this position. Now you are looking at the moon's entire daylit side, so this position represents full moon, which occurs about 2 weeks after new moon. Before we continue, ask yourself what this student will see when she has made a quarter turn to her left to hold the ball or moon in this position. Will she be unable to see the moon as in A? Will she see it as a bright disk as in B? As half dark and half bright as in C? Or as a thin crescent like that shown in D? The answer is C. In this position, the student would be facing us, looking out of the screen. Therefore, she is looking at half of the moon's day side and half of its night side. Be sure to notice that the reason half the moon looks dark is simply because it is facing away from the sun. Contrary to a common misconception, Earth is not casting any shadow on the moon. Also note that while we see half of the moon's face illuminated, we call this a first quarter moon because we see it when the moon is 1/4 of the way through its cycle of phases, about 1 week after new moon. So far, we have seen new moon, first quarter moon, and full moon. Continuing around, the moon reaches this position about 3 weeks after new moon. This is third quarter phase, when the moon looks much like first quarter except with the opposite half illuminated. You can understand the remaining phases similarly. When the moon is here, our student sees only a small portion of the moon's daylight side, with the rest in darkness, so she sees a crescent moon. More specifically, we call this a waxing crescent, because waxing means increasing, and we see more and more of the moon's daylight face with each passing day, from new moon to full moon. She also sees a crescent here, which is shortly before new moon. This is a waning crescent, because waning means decreasing, so all the phases after full moon are waning. When the moon is here, she sees it mostly daylit, but not quite full. This shape is called gibbous, and this is a waxing gibbous moon because it is still on the way toward being full. She again sees a gibbous moon here, but this time it is a waning gibbous moon because it is past being full. To be sure you understand, try drawing your own moon phase diagram. Start with the sun and Earth, obviously not to scale. Using a view looking down from above Earth's North Pole, draw a counterclockwise circle for the moon's orbit. You can remember counterclockwise as the direction the fingers of your right hand curl if you give a thumbs up sign. The Earth also rotates in this direction. We can be slightly more realistic by moving the sun off to the left, so we show just sunlight shining in from the left side of the diagram. The half of Earth facing the sun is in daylight, and the other half is in night. The same is true for the moon at any position, as shown here. Before we continue, check your understanding by deciding which phase of the moon we see in this position. Is it new, first quarter, full, or third quarter? The answer is D, third quarter, because at this position we see half of the moon's day side and half of its night side, so it will look like this. We know this is third quarter rather than first quarter because the moon is 3/4 of the way around from the new moon position. To review, the moon's cycle of phases starts when the moon is here at the new moon position, where only its night side is facing Earth. Over the next few days, we begin to see a little bit of the moon's daylit side, with more each day, so it appears as a waxing crescent. The moon reaches first quarter position about 1 week after full moon. And over the coming days, we see more than half the moon's daylight side, making it a waxing gibbous moon. The moon reaches the full position, in which we can see its entire daylit side, about 2 weeks after new moon. And then it begins to wane, meaning we see less of its daylight side, to waning gibbous, to third quarter, to waning crescent, and back to new at the end of the approximately month-long cycle of phases. You should now understand why we see moon phases and how they appear in our sky. Continue on to part 2 of this video to learn about the times of day at which we see the different phases.